Members of the Tripoli, Minnesota Rocket Club ask a very intriguing question this month. Is time travel possible? Time travel is one of my favorite topics. I wrote some time travel stories in junior high school that used a machine of my own invention to travel backwards in time, and I have continued to study this fascinating concept as the years have gone by. We all travel in time. During the last year, I've moved forward 1 year, and so have you. Another way to say that is that we travel in time at the rate of 1 hour per hour. But the question is, can we travel in time faster or slower than 1 hour per hour? Or can we actually travel backward in time, going back, say 2 hours per hour, or 10 or 100 years per hour? It is mind-boggling to think about time travel. What if you went back in time and prevented your father and mother from meeting? You would prevent yourself from ever having been born. But then if you hadn't been born, you could not have gone back in time to prevent them from meeting. The great 20th century scientist Albert Einstein developed a theory called special relativity. The ideas of special relativity are very hard to imagine because they aren't about what we experience in everyday life, but scientists have confirmed them. This theory says that space and time are really aspects of the same thing, space-time. There's a speed limit of 300,000 kilometers per second or 186,000 miles per second for anything that travels through space-time, and light always travels the speed limit through empty space. Special relativity also says that a surprising thing happens when you move through space-time, especially when your speed relative to other objects is close to the speed of light. Time goes slower for you than for the people you left behind. You won't notice this effect until you return to those stationary people. Say you were 15 years old when you left Earth in a spacecraft traveling at about 99.5% of the speed of light, which is much faster than we can achieve now, and celebrated only 5 birthdays during your space voyage. When you get home at the age of 20, you would find that all your classmates were 65 years old, retired, and enjoying their grandchildren. Because time passed more slowly for you, you will have experienced only 5 years of life, while your classmates will have experienced a full 50 years. So, if your journey began in 2003, it would have taken you only 5 years to travel to the year 2053, whereas it would have taken all of your friends 50 years. In a sense, this means you have been time traveling. This is a way of going to the future at a rate faster than 1 hour per hour. Time travel of a sort also occurs for objects in gravitational fields. Einstein had another remarkable theory called general relativity, which predicts that time passes more slowly for objects in gravitational fields, like here on Earth, than for objects far from such fields. So there are all kinds of space and time distortions near black holes, where the gravity can be very intense. In the past few years, some scientists have used those distortions in space-time to think of possible ways time machines could work. Some like the idea of wormholes, which may be shortcuts through space-time. This and other ideas are wonderfully interesting, but we don't know at this point whether they are possible for real objects. Still, the ideas are based on good, solid science. In all time travel theories allowed by real science, there is no way a traveler can go back in time to before the time machine was built. I am confident time travel into the future is possible, but we would need to develop some very advanced technology to do it. We could travel 10,000 years into the future and age only 1 year during that journey. However, such a trip would consume an extraordinary amount of energy. Time travel to the past is more difficult. We do not understand the science as well. Actually, scientists and engineers who plan and operate some space missions must account for the time distortions that occur because of both general and special relativity. These effects are far too small to matter in most human terms or even over a human lifetime. However, very tiny fractions of a second do matter for the precise work necessary to fly spacecraft throughout the solar system.